Hi guys. As you can tell, I am not there today. I got home and my daughter was super duper sick. So I'm gonna stay home and take care of her. Hopefully she feels better tomorrow. But we're gonna go ahead with the lesson for 2.8. It's the inverse function. You guys have seen this before in Algebra 2, but we're just gonna go over it again. We're gonna talk about finding inverses graphically and algebraically today. So if you could please make sure that you have your notes downloaded or uploaded, however you say it, into Notability, because these are going to be due at the end of the class period. You guys do have a web assign that is due tomorrow morning, and we will go over it, any questions that you have and stuff, and we'll start working on a test review on Thursday when I come back. So when we talk about the inverse of a function, guys, inverse means opposite. Right, you're going to have a function that's said to be 1-to-1 with a domain of A and a range of B. Then its inverse, f-1, has a domain of B and a range of A. Right, they're going to kind of mirror each other. When we talk about inverse notation, when you guys find the inverse, I need you to write f-1 of x. If it's g, it's g-1. If it's h, it's h-1. Because we write everything in function notation. Remember, function notation is just a funky way of saying y. Well, when you say the inverse, f-1 of x, you're actually calling that x. These are the inverses of each other. So anytime you have an inverse, you have to have your inverse notation, that little f-1. It's not f-1 like that. That's f of -1. It's f with a little -1 up here, and then your x value. So make sure you guys have that. An inverse is categorized like this. If you have x values, right, I have all these x values, and then I have all these y values. This is my original function. Your inverse switches the x and the y values. So on a graph, I'll show you how it mirrors and how it changes. But if you have a set of ordered pairs, if you have functions or something like that, your x and y values switch. So in a case like this, you guys are seeing all these things. It says f of 1 equals 5, f of 3 equals 7, f of 8 equals 10. These are just ordered pairs. This is saying when I plug in 1 for x, I get out 5. When I plug in 3 for x, I get out 7, in whatever formula you're using. And when I plug in 8 for x, I get out -10. So they're telling you here, they're asking you to find the inverses or the opposites. So think about this, guys. The inverse of 5 is going to be 1. The inverse of 7 is going to be 3. The inverse of -10 is going to be 8. They're opposites. If you were going to write these ordered pair as inverses, the inverse to 1, 5 would be 5, 1. The inverse to 3, 7 would be 7, 3. And then the inverse to 8, 10 would be -10, 8. The signs stay the same, all that stuff. The only thing that changes is the order. They switch places. So if you're going to solve an equation, you're going to find the equation's inverse algebraically. There's some steps that you have to follow. And once you do these steps, you do the same thing every single time, you'll be able to solve for inverses. The way that we do that is you're going to first cross out f of x. You're going to rewrite f of x and change it to the letter y. All right? So we're going to get y. We want y by itself. Then we're going to interchange the x and the y. You're going to switch x and y. Then we're going to solve for the new y. So let me show you what it looks like. All right, here's my function. So this is how you guys would show me on your web assign, on a test or a quiz. You have f of x equals 3x minus 2. So the first step that we do is we change f of x to a y. So y equals 3x minus 2. Then the most important thing you can do here, you have to switch the places of the x and the y. So this becomes x equals 3y minus 2. Once you have done that, you have now begun the process of solving for the inverse, because the inverse is when you switch the places of x and y, which we have done. We now are going to isolate y. I want to get this y all by itself. So we're going to undo everything. Well, what was the opposite of -2? We would say +2. What you do to one side, you do to the other. So I have x plus 2 equals 3y. Well, how do I get y by itself? I'm going to divide both sides by 3. So I end up here, guys, with y equals x plus 2 over 3. You could rewrite that if you wanted to as x plus 3, or x over 3, sorry, plus 2/3 if you want to. But the last step that is so super duper important is you have to write f negative 1. You're telling me this is the inverse. The way you're telling me that this is the inverse is by writing that notation. And you have x plus 2 over 3. That is the inverse. Now, you can kind of go back. Some of you are really good about this. You like to check, make sure your work is correct. So here is my original equation, and here is my inverse. So you can kind of compare the two. You can look at the two and say, well, inverse means opposite, so all of the opposite things should happen. So in my original, I have 3 times x, multiplication here. So if you notice in your inverse, you have x divided by 3. You're dividing. In your original, you have minus 2. In your inverse, you have plus 2. So you should be able to compare your original to your inverse and kind of match up all of the inverse operations, and that should work out every single time. All right, let's do some more here. We'll come back to this one when I'm there on Thursday. I want to make sure I'm there for you. All right, so let's solve these. I gave you guys some problems that we just made up. So the first thing we're going to do is we are going to cross off f of x and change it to a y. And the second thing we're going to do is switch the places of the x and y. Super duper important. So this becomes x equals 2 times y plus 7 squared minus 3. So now we've begun the process, guys. It's really important that you use your order of operations. I want that y by itself. There's a lot of things that have to happen in order to get y by itself. So the first thing we're going to do is we're going to add 3 to both sides. So I'm going to add 3. I have x plus 3. So this is going to cancel out. So I'm left with equals 2 times y plus 7 quantity squared. All right, we still have to get this y by itself. Can't touch anything inside that quantity squared until we get it completely alone. So I'm going to divide both sides by 2. So I'm going to rewrite this so y is on the side. Y plus 7 quantity squared equals x plus 3 divided by 2. Now, guys, how do you get rid of quantity squared? We're going to have to take the square root. What you do to one side, you do to the other. But think about this. This is an even root. So what is going to go in front of my square root sign? This has to have a plus or minus here. So x plus 3 over 2 is all underneath the root. And the last thing we're going to do is minus 7. So this problem, excuse me, works out to be y equals negative 7 plus minus the square root of x plus 3 over 2. And I'm missing one thing. If I leave my answer like that, say this is a 10-point question, I'm going to take off 2 or 3 points because that is not notation for this is my inverse. This y needs to be replaced with f negative 1 of x. This is your answer. If you have g, it should be g negative 1. If you have an h, it's h negative 1. But go ahead and look and see if everything is opposite. If in my original, I'm adding 7. In the inverse, I have a negative 7. In the original, I'm squaring. In the inverse, I'm taking the square root. In the original, I'm subtracting 3. In the inverse, I'm adding 3. And in the original, I'm multiplying by 2. In the inverse, we're dividing by 2. So it's just a good little thing to go back and check. All right, so if I look at number 2, again, I'm going to change f of x to y. So I have y equals x squared plus 4. I'm now going to interchange the x and the y. So x equals y squared plus 4. So now we're going to isolate y. I'm going to subtract 4 from both sides. I'm going to move y squared to this side. Y squared equals x minus 4. And the reason I put it in parentheses is because I have to take the square root here. When I take the square root of one side, you take the square root of the other side. It's the entire side. And when you put a square root on, what goes in front? Plus minus, since it's an even root. So this is y equals plus minus the square root of x minus 4. Again, I cannot leave it like that. I have to finish my problem with the inverse notation. So f negative 1 of x equals plus minus x minus 4. So check. Compare. Squaring x, we're taking the square root. Adding 4, we're subtracting 4. So we're good to go. So looking at number 3, again, algebraically, we're going to figure out if this has an inverse or not. So we're going to switch x and y. So y equals negative 5x squared plus 3. I'm now going to switch the places of x and y. So I have x equals negative 5y squared plus 3. Now we work on isolating y. So I'm going to subtract 3 from both sides. I have x minus 3 equals negative 5y squared. We're going to divide both sides by negative 5. So y squared equals x minus 3 over negative 5. And then we're going to take the square root. So since I'm taking the square root, I put my plus minus on top. I have x minus 3 over negative 5. And I replace my y with f negative 1 of x equals plus minus x minus 3, square root of x minus 3 minus 5. Okay, guys. Lastly, we're going to look at this one. Again, we're going to just undo everything. All right, I'm going to start off with saying, okay, I've got to replace f of x with y. So I have 5 minus 3x divided by 2. Now we're going to switch the places of x and y. So x equals 5 minus 3y divided by 2. Now we're going to go ahead and we're going to isolate y. So to get that divided by 2 out of the denominator, we're going to multiply both sides by 2. So 2x equals 5 minus 3y. I'm now going to subtract 5 from both sides. So 2x minus 5 equals negative 3y. And then lastly, we're going to divide by negative 3. So I end up with y equals 2x minus 5 divided by negative 3. And again, we have to make sure, guys, that we write in our function notation. So f negative 1 of x equals 2x minus 5 divided by negative 3. And you can go back and compare. Compare your original to your inverse. In the original, we were dividing by 2. In the inverse, we're multiplying by 2. In the original, I had a positive 5. In the inverse, I have a negative 5. In the original, I was multiplying by negative 3. In the inverse, I'm dividing by negative 3. So you can always go back and algebraically kind of check yourself just to compare. All right, guys, lastly, we're going to talk very basically about the inverse of a graph. Or inverses graphically. Okay, when we talked about reflections in our transformations, we talked about reflections over the x, reflection over the y. So it either flips up and down, flips left and right. If you have a function that has an inverse, it's going to be reflected over this line, which is y equals x. So in a case that you have, like, you have a couple points. Say we have the point 1, 5, and we have the point 3, 7, right? So my function, I'm going to go 1, 5, 1, 2, 3, 4, 5. Point here and then 3, 7. 1, 2, 3, and then 7. My inverse is going to be the opposite. I'm going to switch. So this is going to become 5, 1. This is going to become 7, 3. So my inverse is going to be 1, 2, 3, 4, 5, 1. And then 7, 3. So 5, 6, 7, 1, 2, 3. So here. So if you notice, it's a mirror image that just happens to reflect over that line y equals x, that diagonal line through the origin. So, which is just exactly what I just said. If you are given the points A and B, or B, like B and A here, if you flip the B and the A, you flip the domain and the range, you flip the x and the y, it's going to create a mirror image, but it's going to be reflected over this diagonal line, y equals x. So just a visual representation for you guys to see. Like if I have this blue function right here, this squiggly looking thing, okay? And if you were to graph it as the inverse, you have the same squiggly looking thing. It's just reflected over that line, y equals x. So guys, please finish up the notes as you went through the video. Hopefully you were super good for the sub. I really appreciate it. Thank you very much. I will see you on Thursday. Please be safe driving around and get your web assigned done so we can go over it Thursday in class and start our review. Our test is going to be next Tuesday, the 15th. So I'll see you guys Thursday.